In today's video, we are going to find expression for energy density in electromagnetic waves. We know that in electromagnetic waves, variation of electric and magnetic fields are perpendicular to each other. Here, the electric field is shown by red color and the magnetic field is shown by the violet wave. So there are the two waves, they are both perpendicular to each other. So this is y-axis and this is z-axis, and the resultant electromagnetic wave is propagating along x direction. The expression for electric field is given by E equals to E naught sin omega t minus kx. It is called sinusoidal wave. If any wave having this type of wave shape, and it is expressed by using sin of omega t minus kx, then that type of wave is called sinusoidal wave. So in electromagnetic wave, the electric field is sinusoidal wave, as well as magnetic field in electromagnetic wave is also sinusoidal. So both are sinusoidal, but both are not same direction. Both are not vibrating in same direction. They are vibrating perpendicular to each other. So angle between electric field and the magnetic field in electromagnetic wave is 90 degree. They are perpendicular to each other. Here we need to find energy density of electromagnetic wave. For that, we need to find energy density of electric wave, and we have to find energy density for magnetic wave. That is, we have to find out U suffix E, and for magnetic wave U and the suffix B. That is the energy density for magnetic wave, and UE is the energy density for electric wave. Therefore, energy density of electromagnetic wave equals to addition of energy density for electric wave plus energy density for magnetic wave, that is U EMW equals to U with suffix E, that is the energy density due to electric wave, plus U and suffix B, that is energy density for magnetic wave. Now we need to find out what is the value of U, E and energy density for magnetic field, that is UB, equals to how much. Since E equals to E naught sin omega t minus kx, now energy density associated with electric field is given by half epsilon naught E square, where epsilon nothing but permittivity of free space. Therefore, energy density due to electric field equals to half epsilon. Now putting the value of E, that is E naught sin omega t minus kx whole square. So this equals to half epsilon naught E naught square and sin square of omega t minus kx. Call it equation number 1. B is given by B naught sin of omega t minus kx, and let us say UB is the energy density of magnetic field, and that is UB equals to half mu naught multiplied by B square. Therefore, half 1 upon mu naught multiplied by B, that is nothing but B naught sin of omega t minus kx whole square. So this is equals to half 1 upon mu naught B naught square and sin square of omega t minus kx. Call it expression number 2. Here I would like to clear one more thing. Both these equations, the equation 1 and this equation 2, both are valid in vacuum or free space. Why? Because we have utilized here permittivity E naught, that is valid for free space or vacuum, and permeability B naught, that is also valid for free space or vacuum. Therefore, here we obtained UE and UB. Both equations are valid as long as the electromagnetic wave is traveling in free space or in vacuum. Now, since energy density of electromagnetic wave is nothing but addition of energy density of electric wave and energy density for magnetic wave, we have to add equation 1 and equation 2. So we get the total energy density for electromagnetic wave is nothing but UE plus UB. So now adding both the equations, and after adding both the equations, taking half sin square omega t minus kx common. So in the bracket we left epsilon multiplied by E naught square plus B naught square divided by mu naught. So this is nothing but energy density for electromagnetic wave. Now to find out average energy density of electromagnetic wave, we need to take average value of sin square of omega t minus kx. That is nothing but average value of sin square omega t minus kx is nothing but half for a single cycle. By mistake I have written here m, it was E for electromagnetic wave. I am correcting it. Therefore, average value of electromagnetic wave is nothing but half, and average value of sin square omega t minus kx is nothing but half, and here epsilon E naught square plus B naught square divided by mu naught. This can be written in another way as well, as that is, we can open the bracket. So 1 upon 4 epsilon multiplied by E naught square plus 1 upon 4 B naught square divided by mu naught. Call this equation as number 3. And one more important thing, according to Maxwell concept, in electromagnetic wave, energy is shared equally between electric and magnetic field. So we'll prove that 1 upon 4 epsilon naught E square equals to 1 upon 4 B naught square divided by mu naught. We will prove it now so that we can further simplify the equation number 3. So taking LS, and we know that E naught divided by B naught equals to C, implies E naught equals to C multiplied by B naught. What is C value? C nothing but velocity of light. We already proved this equation in our earlier video, that the ratio of E naught and B naught equals to velocity of light. Therefore, 1 upon 4 in place of E naught, we are going to write C multiplied by B naught. So C multiplied by B naught whole square. This is equals to 1 upon 4 epsilon naught C square multiplied by B naught square. This can be written as 1 upon 4 epsilon naught into C naught square into B naught square. We also know that C equals to 1 upon under root of mu naught multiplied by epsilon naught. Squaring both sides, C square equals to 1 upon mu naught multiplied by epsilon naught, implies C square multiplied by epsilon naught equals to 1 upon mu naught. In this equation, in place of epsilon into C naught, C square, epsilon naught into C square, in this we can replace it by 1 upon mu naught. Therefore, 1 upon 4, and replacing epsilon naught and c square by 1 upon mu naught. So 1 upon mu naught multiplied by b naught square. This is equals to 1 upon 4, 1 upon mu naught multiplied by b naught square. Therefore, 1 upon 4 epsilon E naught square can be replaced by 1 upon 4 B naught square divided by mu. Therefore, in equation 3, replacing 1 upon 4 epsilon E naught square by 1 upon 4 B naught square divided by mu naught. In place of this we have written, and the other part is already there. Writing it as it is, B naught square divided by mu naught. This is equals to half B naught square divided by mu naught. This is nothing but average energy density of electromagnetic wave, that is equals to half B naught square divided by mu naught. R over R average energy density of electromagnetic wave is also equals to half epsilon naught E naught square. So finally we got two expressions for average energy density of electromagnetic wave, that is half epsilon E naught square equals to half B naught square divided by mu naught. So this gives the expression for average energy density of electromagnetic wave.